Hello everyone and welcome back to the Empty Space In Between. It's our first one back after our little hiatus.
Little 2 weeks hiatus, or was it a week? I can't remember now.
It could be a few actually, because we did plan something but it didn't work. So you didn't have anything that week, so...
Yeah, we did try something, but it failed.
Work. So episode 30, and we're back again with another really, really interesting guest, or we think they're going to be anyway, and that is Professor Stephen Longmore.
Hey!
Oh, thank you.
Thank you for giving us your time.
Oh, it's great to be here.
Yeah, so we know you as someone who works in the field of astroecology.
That's right.
So we know that because when we did our data science masters, they came in and gave a talk about us. But for those who are unaware, if you are, do you want to give a little introduction into yourself?
Absolutely.
What you do?
Yeah.
Okay.
Research? So my day job, I'm an astronomer or an astrophysicist. So I study how stars form, where does planets, like how do planets get there, where's their life in the universe. That's my, I guess, day job. But I've, over the last few years, been trying to take astrophysics techniques and apply it to problems a little closer to home. So things like biodiversity loss and climate change. So this astroecology is basically trying to use astrophysics techniques to solve ecological problems. And that's kind of what I do in my night job, I suppose.
Nice. That's sick. I love that's what one of the things I love the most is the ability to, like, that's why I kind of like machine learning. This is very off topic, but like is the ability to apply it in different,
I love it,
in
and
different
it's
areas.
good, like meeting different people with different ideas and perspectives. It's really,
and as you say, you go into a different field and everyone has a totally different idea, but then the methodology still stays.
And you can apply it in different areas, and it's so cool when you find someone that and you say, hey, we'd like this work, and then it does work, and then
they see that, like, I did one for. This was very left field, so obviously I work in a lot in healthcare.
Yeah.
We did an application in for a non-profit who work in like censorship. So we did an index on the freedom of like democracy or freedom of, like the index on censorship that they published, like, so from one being good censor, the other using like the same clustering techniques I use elsewhere, and it just works straight away, and it is quite cool seeing it in people's face and like, wow, this is
yeah. Particularly when they're not used to it, and you show them it, and you give them new insights into something they hadn't before.
Yeah, into something which they spend the whole days looking at, and then you see the re-excitement for their field. But yeah,
I just remember being when we got that talk at master's level. From some astroecologists in your department, who the names are now, forgive me, I will never know. I've forgot them.
Yeah. Slept since then.
But yeah, talking about like cross application, I remember just being mind blown because I've always loved animals. I've kept animals my whole life. Then as a mathematician, you felt locked out of it, and you were like, I'm just dealing with data sets and that. And then you were like, no, we're looking at animals through the sky. And I was like...
data is data.
Yeah,
it doesn't matter where it comes from. And applying it, that's the amazing thing about maths and these machine learning techniques is that, if you've got a good idea and you've got a technique and you've got a question you're trying to solve, then...
Get some data and you're on your way, that's it.
Right, so we'll delve into that a bit more later. But where we start with all our guests is we like to break the ice a bit and ask some three... We started calling them highbrow, but they're really not. 3 questions.
They are highbrow.
I spent a lot of time thinking of these. So the first question that we always ask all our guests is, what is your favourite sandwich?
Favourite sandwich?
Always a head scratcher.
That is an absolute...
You will be judged tremendously.
I will be judged.
Judged and ridiculed.
We've had some goodies and we've had some absolute terrible sandwiches.
Had some stinkers.
This is painful.
So burgers are included within the sandwich sphere. We had a burger shout the last time.
I mean, this is so lame, but I tend to have wraps more.
Yeah?
That's fine.
All right, okay, all right, cool.
Right,
so this is the recipe for, I think, an absolute smasher of a wrap.
Okay,
right.
I am.
You got your wrap.
Yeah.
Falafel. I do like a bit of cheeky falafel.
I like falafel.
Falafel's lovely.
Falafel, cheese on top. Bang it in the micro. 1 minute, comes out melted, juicy. Tomatoes, lettuce, hot sauce, the killer. So I go around the world, I collect hot sauce.
Are you a hot sauce?
I bang in, yeah, hot sauce, a little bit of sweat after.
Are you one of them for the spicier the better, or has it got to be with flavour, bit of balance?
Bit of both.
What's the best hot sauce you've had then?
So I just got back from Madagascar, and they have like wickedly good hot sauce, and it's so good because the ingredients are fresh. And so I've that's my current favourite.
That's decent, man. So falafel with melted cheese. What type of cheese are you going for?
I've got to say it's standard cheddar. Standard
Cheddar.
Cheddar, you
Don't
can't
want to
beat
push
cheddar.
that out too much.
You
You're
can't beat
mixing
cheddar.
culture there.
I know.
like
Well,
English
that's it.
cheddar.
It's like me. It's a melting pot. My rap is like a microcosm of my philosophy of life. It's just
like
bringing it
it.
all together. All the things you
I
like.
thought you were going to say
in a rap.
something exotic then, just no, straight up still
straight-
on top. You know what I mean?
Cheddar.
That's
Just
it.
it's like all the things I like from different parts of the world.
Nice, man.
So then
That's
what's
decent.
tomatoes, lettuce,
Lettuce,
hot sauce.
Hot sauce.
What's that program that does the wings with the hot sauce?
Oh, I love wings.
Is it-
Nice.
Is it just called
Hot ones.
Hot ones.
Hot ones.
Hot ones.
And they have like 10 wings with celebrities, and
seen
then
that?
they go up in
and-
spice at every wing.
Right.
And the M1's like made out of like what's
the
it called? Ghost peppers
they
and
are,
that.
Yeah, brutal. I've never actually
Yeah.
had one of those, but
Yeah, so they ask them like progressively harder questions as they
Right.
start getting more in pain. It's quite good. Like, it's quite
internal and
funny.
external pain. Yeah,
Yeah.
exactly. Nice.
So you know what? I like that. That's up there in the top. That.
That's up there because we've had some baddies here in Malabar. I still give them hate every week for saying a cold sliced chicken on white bread with
With
cold
peppers.
peppers.
Oh, do you know what? There's nothing more depressing in life than seeing someone with like white bread, like a bit of the cheese that you take out of.
You
peel,
unfold it.
you unfold the cheese
Yeah.
with some like
Plastic
processed ham
cheese.
and no butter, and it's just like, what kind of life are you living, dude? Like, this is,
Yeah, you just cry over your sandwich.
It's like, I
Yeah.
feel sorry.
You walk past the computer screen, there's just nothing on it. They're just sitting looking into darkness with
Their own reflection as they're
Oh,
eating.
no.
plays in the background. Hello, darkness, my old friend.
Yeah, exactly. I'm gonna get some hate email from my colleagues, but
It's all deserved
yeah.
on them, not
Yeah,
yourself.
yeah.
So the second question
Yeah.
is, I think it's the famous one. 3 people, dead or alive, who would you invite round for
3 people.
a lovely dinner party?
I would love Sir David Attenborough. No question.
Yeah.
He's just an absolute ledge.
a
If I could
mensch.
meet him, I would. Michael Palin
Michael Palin, okay,
Yeah.
from Monty Python.
from Monty Python,
Yeah.
and I know I like traveling, and he's been.
There's a lot of travel programs,
Yeah,
doesn't he, over the last
yeah.
20 odd years?
And
Yeah.
he's just, I think he's funny, witty. I think you'd have a good laugh.
I love
So I
Monty
think
Python,
I'd love
man.
to hear David Attenborough's stories. Michael Palin, I reckon he has good pants. The third one. No, I'm struggling with the third one.
It can be a friend. It doesn't even have to. Could be family member.
No, it'd be someone I'd never met before. Someone who's done something really cool. Somebody like someone who's really made a difference in the world. Like your kind of Nelson Mandela's.
Yeah,
or
someone
someone like
of
that.
that
So
ilk.
I can't put my
Finger
finger on
the
it, but it'd be
person.
someone like that.
Someone really
Someone-
influential, someone
yeah.
who changed
Exactly.
something
So you like
huge.
corpses? Are they like? Can I have Nelson Mandela corpse? No.
Yeah,
We're
wheeling in.
alive. No.
Yeah. Now let's just wheel him in.
Yeah.
And then the final question is, what's the worst job you've ever had?
Oh, I've got plenty. So
A
I was-
job where you think I would not go
Okay.
back if I had
Do you
no
know what?
money for the
in
rest
all
of my
honesty,
life.
this is one reason why I'm here now. Is because when I was growing up, trying to save up money, I had some pretty bad jobs. So I think I can give you some of my worst shifts. I had one. I used to work in a sort of pub eatery place near where I grew up, and I had one shift where I was just told to peel potatoes and to grate cheese. And I had like a 4-hour shift, and that's literally what I had. This big party.
Was it cheddar?
It was cheddar. It was a massive block of cheddar. And you grate it was like they didn't have machines to do it. It was just like, 'cause I was like a kitchen porter, so I was getting
Just
Yeah.
dripping in sweat.
yeah, exactly, dripping
and-
sweat out there. So that was I had a job at, I wouldn't mention the company, but there's a company that has warehouses, and we used to. So the boss I had was an absolute nightmare, and so like it would have made the job terrible, but except everyone that was underneath him was like, right, we're not putting up with this. So we used to take turns, like, it was early, they'd bring in the crates and you'd have to deal with the crates, and we used to take turns sleeping in between the crates just while he was, so we have one person looking out and then we take a kip, just
So how
take
old was
the-
you when this is happening?
So the first one I was like sort of 15, 16,
FAP,
and then
yeah.
it was
yeah.
in between. I finished my undergraduate and I was saving up to go to uni, so I was doing 2 jobs. I was working at a petrol station for 8 hours and then this other place for 8
man.
hours, yeah, just to save up the cash.
You had a lot of jobs down, haven't you?
Man,
Yeah.
yeah, I've but that's a pretty.
They're the worst ones.
But doing that, it's I appreciate what I've got now.
Yeah,
having
yeah.
worked through and done that.
And
it's-
worth
yeah,
ethic as
exactly.
well, and teaching
Yeah.
Yeah,
because
to get up
I
and
worked
go.
all the way through like my undergrad. It was nothing as bad as like in warehouse and that, but it was Nando's. Obviously,
Yeah.
you know Nando's.
Yeah.
If I said that like it was like a fucking off-brand, independent family-owned thing.
You know that really
You know,
obscure place.
you know that really. There's one round the corner.
It's a restaurant no one knows about.
Nando's.
Nando's.
Yeah, so I worked there for like 5 years. But as you
Right.
say, like when I got out of there, I was like, oh my god, thank
Yeah.
you fuck for that.
Absolutely. No, I
so hard.
sympathise so much with that.
It's just a pain in the ass, and they're just not bothered, are they?
No.
At the end of the day.
Yeah.
But yeah.
Big companies, they're not like, they just let you.
Like obviously you have the odd people on the ground who try to care, but
yeah, exactly. I mean, and honestly, I mean, if you've worked with good people, you can have the worst job in the world, but if you're having a laugh,
can have a laugh.
and you have
Yeah,
a dance,
that's-
I worked
you're-
on building sites every summer,
Yeah.
and no one likes digging holes.
Yeah,
it's
but
not
if
fun.
but you got the right people.
But you
Yeah,
can have
totally.
a proper laugh
Totally.
there, where like you're thinking, if it was just me digging a hole, I'd be gutted.
Yeah.
But like,
But I've got my mates.
yeah, I've got some and then
Yeah.
I feel like in those jobs as well, you end up being mates with like you're 17, but you're mates with like a 62-year-old
Yeah.
fella,
Yeah,
and
yeah.
you're
That's
just
the
like
best thing,
coming in like,
exactly.
what's happening?
Who's
mate?
got like completely different life experience, and you
Yeah.
just it's
Yeah,
good.
that's
Bit
it.
of a melting pot of
Yeah.
people. It's just quite
That's
fun.
it, man.
But right, no, they're good answers then. Like, I like
Well,
it.
yeah.
They were
Well,
a solid
they were honest.
set
I don't
on
know
the
if they
three.
were.
I like it.
I feel like some falafel now.
You know what? I might actually go for some later.
Some cheese on.
Well, I've not had falafel in ages. But right, so as you said, astrophysics.
Yep.
Your first love, as
Yep.
it were. So when did that like come about? When did you know? Oh, this is this for me.
Honestly, so I
Where did your desire for the stars
for the stars come from. I mean,
initiate?
I did physics at uni,
Yeah.
and then I did a course on astrophysics. And so my dad's an astrophysicist, so this was a big thing. I was
okay.
never ever going to do astrophysics.
That's what your dad does.
That's what my dad does, and it's just like it's lame, and I don't, and I had all these like I'm going to go off and do my own thing. But I did physics because I enjoyed it, and I went to uni and I did a course on astrophysics. I was like, actually, I quite like this. This is
like, it's
dangerous.
actually quite sweet.
Yeah, it's actually
Yeah.
I quite like it, and yes, that was it. So I did some courses, and I love it. I love the big questions. I love the
Big
what's out
philosophical
there.
questions.
I love
yeah.
that, and I feel privileged that I can try and
Answer them.
try and answer. They'll never be answered in my lifetime, but if I can play a small part in it, I know. So yes, that was it. So basically, undergraduate, I really enjoyed the astrophysics courses, and then I just kind of went from there.
So was like staying on like in academia, was that always the way, or did that come later?
No, I really wanted to do a PhD. So I was saying when I was doing this job in the warehouse
Yeah.
place, so I saving up, and I wasn't. So I'm half Australian. My mum's Australian, so
Okay.
I wanted to go to Australia, and I chose. I wasn't think this just shows you how far ahead I was thinking. Is that I chose a university that was next to the ocean because I wanted to do surfing. I wanted to do
So
a
I can
PhD.
run out with me
Yeah,
backpack,
exactly.
legging,
Yeah, exactly.
just run to the beach.
So I did. I went to Australia because about half my family's there. I didn't know them that well.
Yeah.
So that was that. I wanted to do my PhD, but I thought, going to Australia, bit of beach
Yeah.
action. Yeah. So
Two birds, one stone.
absolutely.
All that. Yeah.
So,
So even though your dad done astrophysics and you were thinking I'm rebelling against that,
Yeah.
you
I
literally
got drawn
moved to
in.
the
I
subject.
got drawn in. I know it's terrible.
Thought you were going to say so I went and majored in art and drama,
Yeah.
and then went back and ended
No,
up
no,
doing
it's
it.
terrible. It's no, I'm not that. I'm far more dull than that, I'm afraid.
No, but it's a great topic, man.
So how long have you been now in research and academia?
So I finished
been
my
involved?
PhD 2007. So I've been doing sort of my own research.
Since then?
Yeah, since then.
So what would you say is the most kind of important, influential, or even just like the thing you were excited about
Yeah.
it's in like your whole research time?
So that I've done, or that other people have done.
Or
What
you
you've
or
done to
other
start
people?
with.
So
Start with you,
yeah,
and then we
okay,
can move on to
okay.
the field in general.
I think the thing that I'm really excited at the moment is that we found that where stars and planets are in the galaxy can affect how the sort of the habitability of the planets. So we typically tend to think when in the field of when we're looking at we discovered lots of planets around nearby stars, and we're getting to the stage that we can measure their atmospheres and potentially are these habitable for life. Well, the current thought is that these planets, like the sun, we just sit here and we're in our galaxy, we're in our star city, but we don't care about the other stars. The recent work that got me really excited was we found that actually that can change. So if you basically pass if you're in a high density of stars, then that can lead to your planetary system getting messed up, changing the orbits of the planets.
Okay.
And so we found these planets called hot Jupiters. So they are these very massive planets.
Like huge gas planets.
Huge gas giants that end up, and they're weirdly close to their star. We don't know how they get there, because our solar system, Jupiter's way out, thankfully.
Yeah.
So if
The
it was
smaller planets are closer.
and the smaller planets are closer, and that's great, because that means we've got this lovely planet that can host life and stuff. And Jupiter is important because it plays an important role.
Isn't it like our bodyguard, essentially?
Exactly. So that's good for us. But most stars that we observe, the planets around them, their Jupiters are super close in. And so what the paper that I was really excited about was saying that the reason Jupiter's could have started out, and then maybe because another star moved too close to it, that it ended up, it like messed up the system, and that Jupiter ended up crashing in towards the center. So that is, if that's true, then that has big implications for where we might expect to find life in the universe.
But isn't our like old assumption that a planet could only, most probably hold life if it's in these traditional Goldilocks zones?
Absolutely.
Is that what you're saying?
Absolutely.
Now we can get outside the boundaries of that, possibly, or Goldilocks zones are now opened up to.
No, I think conversely, that this star system might have had a Goldilocks zone, but then another star went too nearby it
And just smashed the Goldilocks zones a bit.
Yeah, so the Jupiter's just coming and going woof, and it's kicked out.
So essentially now this paper discovered that these solar systems are not kind of these like isolated systems.
Exactly, that
and
just
they
sit
can be
there like
affected.
this forever. They can be so the assumption is that once you form a bunch of planets, and so you form 10 planets, and they're this massive and they're this far from their star, then that's it.
It's like
For
a stable.
eternity, it's stable. But what our paper seemed to show was that actually you can mess that up. There are ways that you can mess that
Why
up.
would the star move though, Stephen? Is it because galaxies are colliding, or is it?
I mean, no. Just our galaxy has like 100 billion stars, so there's more stars in our galaxy than there are grains of sand on Earth, right? I mean, the number's mind-boggling.
Yeah.
And they're orbiting around the center of the galaxy, so are passing by each other, and usually they pass by so far away that they don't feel each other's gravity, but occasionally,
every now and then,
just because they're moving on just kind of random paths, that they can come close and they can mess each other up. And that's what we found, is that might explain why we find these hot Jupiters. That was
sick. So what? How does a Jupiter being close to a star expand a possibility of planets that could be habitable?
Well, no, I think it shrinks it.
Shrinks it okay.
Because that system. So say we go out and we observe, and the way we find these is we look for the star wobbles, right?
Yeah,
'Cause
okay.
if you've got a Jupiter next to a star, it makes the star wobble, and we can detect that wobble, and we find lots of stars have this wobble. But maybe if we were to look 100 million years ago or a billion years ago,
They weren't wobbling.
They weren't wobbling. Maybe the Jupiter was miles away, but it was only that at some point in the previous history of this star's life, that another star got too close, and what was a beautiful habitable system then got wrecked, basically. So that's what.
And this is research that's directly coming out of your sort of group.
Yeah, exactly.
Wow.
So there's a new telescope that was, well, I guess it's not that new anymore, called Gaia, which measures how stars are moving to exquisite accuracy. So stars near the sun, so we can measure how they're moving through the galaxy, and we can start to look, we can compare the planet populations in regions where there's lots of stars, and we can compare that to planets where there's regions with not many stars, and we find that there's a difference in the properties of planets in these high density regions and low density
because
regions.
their solar systems are more likely to be affected by neighbouring stars.
Exactly. Potentially. That's a hypothesis. Now, it's a science, so it could be total nonsense.
It could,
but that's
needs
a
to be
hypothesis.
tested.
Yeah.
But this is what the hypothesis that's come out of these findings.
Exactly. So we published that a few years ago, and that's what we.
That's insane.
Yeah. So
wow.
I love
there
that.
we go.
So, what would you say is then the biggest finding, or the most thing you find interesting in the field as a whole?
As a whole. So I mean, there've been several things recently. The one thing that's most closely related, and I love astronomical things that happen on human timescales, because most of the stuff is it takes millions or billions of years for anything to happen.
Yeah,
right?
this is happening in 4 billion years.
Yeah, exactly. Take a seat, get your popcorn. 4 billion years, right?
And wait.
Yeah, and 4 billion years is a long time.
Yeah.
So I love so there's so the Nobel Prize a few years ago was from someone who's in the kind of area, one of the areas I study, so the center of the galaxy, and they got the Nobel Prize for finding the supermassive black hole that lives right at the center of our galaxy. And the way they do that is by the stars, because the gravity is so intense, the stars are moving close to the speed of light and zipping around, and you can actually see that if you've got a powerful enough camera with sharp enough vision around the black hole, and you can go on, do put it on YouTube and look for one of these experiments, so you can actually see the stars. It looks like they're whizzing around nothing, right?
Yeah.
These stars, because you can't see the black hole, but these stars are moving at ridiculous speeds around, and from that you can measure how massive the black hole is. So they proved that there was this 4 million solar mass black hole right at the center of our galaxy, and I think that, because you can actually, like, you can go on YouTube the movie yourself, like you can physically see it, and you can say and you get it, you know how they've done it. So I think that was really cool.
And what about over the last few years we've seen these like reconstructed photographs of black holes? Is that the one at the centre of our galaxy, or is that a different one?
So there's several. So they've done our own. They've done one nearby galaxy, and they've done our own, the centre of our own galaxy, and that's phenomenal. Like, but both of these, the thing that is really amazing is not just the result, but the technology that they've had to develop in order to make that result is astounding. Like, so for this, the other one, the image of the event horizon. So the event horizon is the bit around the black hole where the material is just about to go forever.
Yeah.
Right? It's about to be sucked in. It's exactly.
Have you seen Interstellar?
Never watched.
Lad.
I know it's on my list, and it's one of them where I always like go, throw it on.
Have you seen it, Stephen?
And I just never.
Do you know what this is? Do you know that there are several things that are so embarrassing? One, when people ask me things like that, and I have to say no or lie.
No, but if you want to, like, I don't know, some type of construct of an event horizon, it's good for.
I've seen some.
Didn't that take him something like genuinely like tens of hours, hundreds of hours to generate one frame with something ridiculous?
Exactly. Yeah.
They tried to get it as accurate as possible with astrophysicists.
And they did a really good job of it.
I'd read about it in books, but up until that film, I'd never seen one in such high res. And that if you want to know what it looks like, basically, it's class.
I do need to watch it.
But to make that, what it's called the Event Horizon Telescope.
Yeah.
And the way it works, I think it's just mind-boggling, is that they join telescopes all around the world to make a telescope that's the size of the Earth.
Yeah.
And that is, to do that takes like a level of sort of engineering and
mathematics.
I've seen that. They calibrate like Gibraltar with Mexico and everything's pointing at the same thing,
it's pointing
isn't
the
it?
same thing, but to a level of precision that is it's ridiculous.
Yeah, jeez.
It's insane, isn't it?
But black holes as a whole, like,
let's see what you did.
Have you looked into black holes much, Stephen? Has that been something?
There's not much to see in it.
No, I don't. That would be amazing if we could.
Just looking at going, this is a waste of time.
Yeah, if I could enter that, I would be a millionaire. I would have a lot of money. But have you done much research around?
Not black holes themselves. So
not black holes themselves.
I study the center of our galaxy because it's an interesting window. So the center of our galaxy gives us, it's kind of like a time machine.
Yeah.
It is the gas and dust. So I'm interested in how stars and planets form. And the gas and dust in the center of our galaxy are very like the conditions that our own Earth formed in. Because you know the Earth and the solar system formed 5 billion years ago, 4.5 billion years ago.
It was like hot and collided with lots of rocks.
Exactly. And the universe 4.5 billion years ago was very different than it is now. So it was a much more horrible place to be.
Violent, when
much more violent. And so to study how our Earth formed, we need to find all these violent regions. So I'm basically, the center of the galaxy is a place that we can use that tells us how our Earth might have formed 5 billion years ago.
Like a time machine, basically.
Like a time machine. That's exactly what it sounds like.
Because it is so, as you're saying, because the centre is almost like cluttered.
Yeah.
It is violent, so it acts in a similar way of which
the way the universe
we would have been acting.
Yeah. So then, for people who may not know or not understand, or even probably for us, because we probably are.
No, I know.
You know. I know it all.
I don't. That's the problem.
So how are stars and planets formed?
Okay, so you start out with a ball of gas. When you look out in the night sky, and if you get a telescope, you can see galaxies, and you see that galaxies are made up of lots of stars, but there's material in between the stars, and that's gas. It's mostly hydrogen, a bit of helium, and some dust. And what happens is that in certain conditions, that gas can collapse under its own gravity. And so if you get a gas cloud that's big enough, it will collapse under its own gravity, and in the very center, it will get hotter and hotter and denser until a point at which it's so hot and so dense that nuclear fusion can begin. So that's basically, you've got a controlled nuclear bomb. That's what the sun is. It's a controlled nuclear bomb, and that is how you form a star. So that's not the end of the story, because not all of the stuff gets into the star. So the stuff that's left that's failed star material, that can collapse itself. It's spinning too fast to get into the star. So that's the thing. So if you imagine, like, you watch an ice skater and they spin, and when they move their arms in, they spin faster.
Yeah,
the exact same principles, like the conservation of angular momentum. That the stuff that's spinning too fast, it's spinning too fast to get on the star, and that's what ends up as the planets. So the leftover star material that didn't fall into the star, that was spinning too fast, that can collapse itself to make the planets. So that is in the sort of essence the basic physical process of.
So we're all basically just like stardust.
We're all stardust.
We
are
stardust.
and
You
I
see that on
mean
a few
literally
t-shirts.
stardust. Yeah.
Do you?
Well, you know when people say it, like you know the type of people, they'll put it up on a Facebook quote. Doesn't matter how bad your day is, we are all stardust.
It's true.
It's true.
It's
yeah.
absolutely
yeah.
true. Well, it's kind of,
So,
I love it.
so where does the gas come from then?
Great question. So the universe started out as gas. So a large bit of the universe that we can see started out as hydrogen helium gas, and over time has just been converted into stars and planets. So it was just there from the Big Bang.
Here's a question that's just come. So I can't remember the technical term, but solar systems that have two stars.
Binaries.
Binary
Yeah,
system.
binary,
Yeah,
or
binary
you can get triples.
So
or, yeah.
You can't think of the word. A mathematician, you didn't know the word binary.
No, but I didn't know if it was like I didn't know if there was a
technical
a-
expression.
An
Yeah.
actual
Something,
physics
yeah.
term.
Okay,
Yeah.
so-
No, we just use binary.
nice and
Sorry,
simple.
we're boring. It's the
Um,
binary. Yeah.
So would planets form in the same way, or is there a slightly
Great
different
question.
way they
That's
form?
a
Because
great
obviously
question. Yeah,
the interactions.
Absolutely, that is a big unknown. We don't know. So it depends to some extent, and I would say it's an unanswered problem. But I'll give my and there are people who this is their whole area. So,
Yeah.
So I will give a sort of my best explanation.
Yeah.
It depends a lot on the separation of the stars. So if you have two stars that are really, really close together, and you get some that are so close they actually touch, so that they can be really super close together, then the planets would care less than, because they just
do you treat it as one kind of
Exactly.
mass?
Yeah, for in terms of the gravity, it's just like one star. Whereas if you have stars that are really far apart, and you have planets that might be in between them, then you can imagine that'd be quite unstable. So the crucial thing for planets is stability. So if you have one star, then that's quite a stable system, because you've got one thing that dominates the gravity, and everything just goes around that. And they might, if Jupiter gets too close to Saturn, then that's nasty things happen. But over a long enough time period, you hope you get in a stable configuration where everything's basically, we're just chilled, we're going around, we're not influencing each other too much. But if you've got two stars that are far apart, then that's much more difficult to get in this steady state or equilibrium.
So the binary star systems make me think of Star Wars.
Well, that's
Oh
what
yeah,
I
like
came from.
Tatooine. And,
Yeah, when he's looking out over Tatooine and the two stars come up.
Yeah.
Yeah, because I was wondering then, was it more the case of, like, as you were saying, stars enter a solar system that already exists?
No.
Or do they is
No.
it created?
It's so the planets and all the material is what's left that didn't make it in the star. So they formed at the same time.
Because you hear a lot then, Steve, about, like, obviously you've done a lot of research in how, what makes the likelihood of planets forming, basically likely, if you like. You see a lot of people talking about, the conditions. It's like threading a needle through or a key through a keyhole, basically. Like, it's so unlikely that the conditions are right.
What, for life?
For life, or yet to form, or for a planet to form
really?
that could have life, not even for life to appear, just for the planet to be possible, to harbour life.
I take the opposite view. I'd be interested. There you go. I can have a debate. I think that
You think it's so likely that it's
right. Well,
I know nothing about this area, so I'm just pondering the question.
Yeah, so I'll say some facts and then get to my position on this.
Okay, that's it.
So as I said before, so let's say there's a few 100 billion stars.
yeah,
We've already said before. that's a load of stars. And from what we can tell, most stars have planets. Okay, so that is, no, we've only studied the stars closest to Earth, so and we've got to kind of extrapolate from there to the rest of the galaxy. But let's just say that there's a butt ton of stars, and most of them have planets. Then the question is, what fraction of those planets are likely to host, to be habitable? And the planet systems we see, there's a complete variety. We're struggling to find patterns in there, but that means that if it's effectively random, then that means that there's going to be a decent amount of planets that could potentially have life. If they're the planet masses are fairly random, and how far they are from their host stars fairly random, if you throw enough stellar systems in there,
you get a distribution.
You're going to get a distribution of them, and a reasonable number may lie in the habitable zone. So I think there's no cosmic conspiracy that there is no life or no habitable planets out there. I think the super interesting question is, okay, then there can be in there, but maybe things like evolution, that it was habitable and then it's no longer habitable, or maybe the step. I think what people are really interested in is not just are there habitable planets. What people really want to know is there life out there, and is there intelligent life? And I think
was Mars ever habitable?
Yeah, I think early in its life, it would have had more of an atmosphere that eventually went off. It couldn't hold on to it. It would have been more habitable,
but not habitable. Essentially.
Well, but we don't know, because one of the things is that we've only got one example of life, and that's on Earth. But maybe there's different kinds of life. Life could exist in different forms. If you had a different environment, maybe life would have evolved.
Adapted to its environment.
Exactly. And that's one of our underlying principles, is this Darwinian idea of things adapt to their environment.
Yeah. Isn't there a distinction, though, Stephen, between a planet that... Well, there is a distinction. Like, obviously, there's so many that could potentially harbour life.
Yeah.
But then what's the probability that you can go to actually... harbouring life, because everything can have potential.
Hit the nail on the head.
Kids can have potential to be footballers, but only a tiny amount end up being footballers.
That is what I think. That's where the frontier of this field is. Is that what is it that makes this transition exactly
starts this chain event?
Yeah, and so we know on Earth it took a long time. So, but to make that jump between just like this primordial soup of like molecules and atoms, and there was just sort of in the sort of proto-Earth, to go to that first step to life took a long time, and maybe that planets could be sitting in the habitable zone, but maybe their star is too variable, so it's sending out a horrible cause, like too many. Too much radiation, or maybe it gets hot and cold, and that means that so there's. I think the planets might be in the right place, but are the conditions right?
Stable
for that?
Enough.
Exactly, and I think that is a key thing. Is I think planets are everywhere, but what fraction stay stable enough? And our sun is amazingly stable, and we sitting at a constant distance from a very stable star has possibly been really important in us being able to have this conversation.
Yeah.
So I think so, but that's exactly what we're discussing in the field. Has
there been any indications that our star has been unstable?
Well, I mean, so we
know. I'm not clued up on it, but I've heard like it's going to expand and it'll eventually become like a massive star and then shrink back down again to like is it a dwarf or something, or a white dwarf? or something?
So it will eventually end up there, but we'll be able to get our pensions. It's not going to happen for a few billion years. So
long gone by then.
Long gone, yeah.
What's the? I can never remember the name of it. I don't think it's a paradox as such, but the theory of that life may have existed, but due to the length of time it takes, it may have already died out before we came along.
Yeah, that's entirely possible.
Is that as equal as kind of the other?
Yeah, I mean, it could be. So there's this famous thing called Fermi's paradox.
I think that's what I'm thinking.
Why isn't the universe teeming with life? So everything I said, then people listening are like, well, yeah, but then why isn't the universe teeming with life? That is
why can't I see it in the when I look up?
Yeah, why aren't I having a drink at the pub with a man with funny green head now? Why isn't
I had a few drinks with them
like after some drinks I feel like myself. So it's called Fermi's paradox, and yes, the universe should be teeming with life. If there's all these planets and they're all habitable and life happens eventually, then the universe should be teeming with life.
So Fermi's paradox, just to go over that again,
Yeah.
what is the what is that actual...
So Fermi's just, I was basically going, I didn't say it, but I was going through Fermi's paradox. Is it right?
Okay.
You take the number of stars in the galaxy,
Yeah.
700 billion, that's loads. What fraction of those have planets? Let's say it's 10%. I'm just picking a number.
Yeah,
But even if it's 1%, or
still quite a lot.
it's still
Yeah.
loads of planets.
Yeah.
And then so you can say what fraction of those planets are habitable, and even if that's like 0.1%,
Yeah.
that's still, hundreds of millions of planets. And then if you say, well, how long does life take? Well, it took us like a few billion years. Then, like, there should be life. The universe should be absolutely teeming with it. So if you just do the basic back of the envelope calculations, the universe should be absolutely teeming with life. And as far as we can tell, it's not. Or maybe it is. We just haven't detected it. So the answer to the Fermi paradox is that it is teeming with life. We just haven't found it yet. Or that there's something that we don't know yet that is a blocker to intelligent life. And I think we really mean intelligent life when we're talking about this.
Yeah, people don't want to find, like, the public anyway. Although it'll be massive news if they find little organisms somewhere,
Yeah,
people
like,
will just go,
we
like,
found bacteria
what's
on
for
other
tea?
planets. It's like, oh, come on, we're funding these guys to find magic. I've got enough bacteria in my house. Like, you don't need to go into space to find that. I can just imagine.
Yeah.
No,
But we
totally.
want to find intelligent life, and that's what the Fermi paradox is. Why isn't the universe teeming with intelligent life?
Why does it seem so empty when
Yeah.
the indication is to the
Exactly,
is
and it's
to
just,
the
I mean,
other
it's
side.
the enormity of space, the vastness, and the number of stars that
And as you say, our planet, like, we evolved over billions of years, but
Yeah.
the problem we have got is the sample size of one. There could be places out there
Yeah.
where 100,000 years something popped up quite good.
Yeah.
1 million
Yeah.
or 2 billion. Or,
Yeah.
We just don't know, do we? We've only got
don't know.
one example, and it's just
But this is like getting back
so
to
annoying.
yeah, it's so annoying. But this is also one reason I love this field is because it's you're working with biologists and sort of chemists who must have to understand the early sort of probiotic
Elements and-
Yeah.
chemistry and you're working with obviously astrophysicists, but like geologists because geology is super important. Like it's really an exciting interdisciplinary area.
Yeah.
Speaking of interdisciplinary, then, so obviously, people watching will know, and we know we've had a conversation before. Me and Sam kind of work with machine learning, AI.
Yeah.
So how's that playing in with kind of this whole space of what you're working in? Is it a new thing, or is it kind of been always there?
Yeah, I mean, I think so. Machine learning has become this sort of arching umbrella term that
People like to use it. It's a
people
buzzword,
like to-
and
it's a buzzword.
they like it on applications.
Yeah, exactly. You much more like to I'm an expert in machine learning and AI. And,
Do you have
neural
data?
networks.
Machine learning.
Yes, exactly.
I only have four data. I only have four
exactly.
data
Yeah,
points.
and that's a genuine problem is that people throw machine learning at it and don't understand it, and it's a black box, and you sort of garbage in, garbage out if you don't carefully
Yeah,
do it.
because I can run a Python script with one line. I like a lot of people. Oh, I've done machine learning. It's like,
Well, so there you go. That's exactly
What
so,
you're telling me? I haven't been doing machine learning.
slowly stand
What?
up. Well,
yeah. So I mean, astronomy is a very data heavy. So I'm an observational astronomer.
Yeah.
And so as opposed to a sort of theoretical astronomer sort of simulator. So it's a hugely data heavy topic, and I've been using, I guess, more primitive versions of machine learning for the whole time. It's the only way to make sense of the data is to try and we're looking for trends. We're looking for trying to make correlations between things, and comparing all this is you pull in data from as many sources as you can. You try and make sense of it. So in that sense, just naturally we use and
just
develop
out of
our own,
necessity.
just out of
essentially.
necessity.
Yeah.
Just it's part of our sort of bread
So
and butter.
do you feel more of a push of it now, though, of like the people saying the AI terms?
Well,
and
it's
stuff,
just
or-
buzzword. I think people, particularly. It's funny. So when like a new algorithm comes on, everyone's like the
Jumps
title,
on it.
Yeah, the title will say classifying planets using new method X.
It's like just to get a paper out, they've pushed that method
That
on
method,
it,
yeah.
and it's like that method makes no sense to use.
absolutely,
We're
absolutely.
fine just measuring it with a telescope and collecting it, and that this works. It's not broke. Don't try and fix it. Type
so
thing.
on the one hand, I applaud that. I think it's good that people are trying to innovate and develop and use new methods. But I think the real skill in I don't know what you do, but certainly I feel the real skill in science is not just throwing everything but the kitchen thing. It's having the right question.
It's understanding the tool.
And understanding the tool and using the right tool to answer the question. So
I
getting the question.
I totally agree, because I've had this conversation a few times with people who try and implement data science and stuff, who don't have kind of the formal background. Or people say to me, what should I learn first? I want to learn data science. Well, you learn the maths first.
Yeah.
Because you've got to learn that to understand what you want to use and why you want to use it. For example, like a place I used to work, a guy used, I think it was something like logistic regression, and his outputs, like for one, like, or like a softmax classification, whatever it was. So the probability summed to more than 1 for what he'd done. I was like,
that's impressive.
Like, so
That means it's always happening.
so he something weird had gone on, but obviously he didn't spot it.
Yeah.
And
if you don't have the fundamental understanding of it.
Yeah. No, but I totally agree with that. I think, but I agree with the sentiment as well, because I see it a lot elsewhere, that it shouldn't be a rush to get new things. It should be a, how does this affect what we do?
Yeah.
And is it needed?
Yes.
Type thing. I do agree with that.
Yeah.
Yeah, and I suppose, like, for example, if you take like a problem here on Earth, like, I don't know, cancer, and you throw a black box model at it, you've only got one element, which is confusion. Astrophysics is already a black box, and now we're going to marry another black box with it. So we don't understand the universe, and we don't understand the algorithm telling us about it, and now we're going to mash them together. And we don't understand it. Exactly. But we have an answer, we have a probability. It's 99% accurate.
What is?
But you know what I mean? It's
No, but as you say, it's about choosing the curve, because there is a time and a place to get predictions.
Oh yeah,
of course.
Predictions are crucial, absolutely crucial. It's just making sure you understand the fundamentals
context
and the context
in which they're being applied.
Yeah.
So moving slightly on from astrophysics onto astroecology.
Yep.
So how did that come about? Because is that a kind of a relatively new area?
Yeah. So probably about 5 years ago now. So I've always been interested in sort of interdisciplinary stuff, but I guess when you're talking about probabilities and random chance, so my next door neighbour turns out is an ecologist.
Okay.
And so he is, he's a world expert on primates and orangutan, and so he's I'd say an observational ecologist, in the sense of he collects ecology data and tries to use that to
in the field. He actually goes out.
I mean, he spent his PhD in the middle of jungles for like literally 6 months counting around.
Some people are cool.
Hardcore. I mean, he's got some great stories.
I spent 3 years behind a desk in Liverpool.
Yeah, man, I suck, man. I fucking suck.
Yeah, exactly. Yeah.
But yeah, so you met
one of those things, and you think I've made wrong career choices. At some point, right?
So this neighbour then is an ecologist.
Yeah. So Sergevic is my next neighbour. So he's this ecologist, and so he was starting to use drones so instead of sort of going through the jungle and manually counting orangutan nests, which is I think the sort of his thesis work, starting to use drones. So drones are coming in; they were big, and so the question is, yes, right, we can now fly drones, we can get loads of data, but how do we make sense of that data? And in particular, how do you find animals? Because animals have, kind of keep going back to the same things, have spent billions of years evolving not to be seen, right?
Yeah.
They want to be camouflaged, they don't want to be eaten by other things. And so it turns out that they were starting to use thermal drones. So drones with thermal infrared cameras that can detect the heat radiation. And the animals, so you're familiar with these thermal cameras that like the police shows where there's a robber hiding in the bushes, and
they just see
and it's just like, come on, man,
see him with the back.
Exactly. Haven't you watched the telly? Don't you know? We can see it. So yeah, you find the guys in the bush. So the same thing. So finding a robber in the bush is the same thing as finding an orangutan in a tree, right?
Yeah.
But and astronomers have been using thermal cameras for, we were some of the first people that developed them to study things like stars and planets in space. So we're used to, really extracting every last bit of information out of images, and so we started working on. I was trying to help basically do astronomy, but pointing down. So doing astronomy.
Just reversing the telescope.
Instead of pointing up, pointing down, and finding animals in the ecology footage was how it started.
Just build on from there. So you started the field of astroecology?
Well, I'm
bold statement, but I'm throwing it out there.
I mean, I don't. Yeah, I feel a bit. So I don't even know if it is a field, to be honest. I mean, it's what we called when we started applying for grants. So this was like Serge and I, and we're like, let's try this. Let's see if we can get this to work. And we applied astro techniques, and it worked. I was like, hey, this is cool. Should we write a grant? So we should actually try and take it to the field and go and count an orangutan or whatever. Like, yeah, cool. Well, we've got to come up with a name for it.
The name's badass. Like
the name's so cool.
Well, I was going to say, my astro colleagues hate it. Because
do they want to call it?
Well, it sounds like ecology on other planets. Like,
I
do you know what I mean?
Yeah.
Like ecology on extrasolar planets. So to them it doesn't. So in my way of thinking it's combining astronomy on ecology on Earth, but there's
it's the techniques you're combining, not the way you're looking.
So I mean, so you could have the other way around. You have ecology astrophysics or something where you're doing ecology on other planets. So anyway, we chose that name and it just kind of stuck. So yeah, so we're now, our little group is our astrocology group.
I love it.
So what are some of the things then that your group's been involved in?
Okay, so
what are you focusing on? What animals he's focusing on? What's the...
So we're actually working with, so we expanded the core group, so it's Serge and I, and now we work with two computer scientists actually.
Okay.
So Paul Fergus and Carl Chalmers, who are black belts computer vision folks, and we take basically any data, and as I was saying, the core thing we do is we find and identify any, if you want an animal, we'll train a model to find it. So it's all about getting the data, doing the tagging, and running the predictions on that. So that's the kind of the core. So we're doing.
So you're working with ecology groups then, who are wanting to look after certain animals.
Exactly. So they will come to us and they'll say, look, we've got 100 hours of footage. We've flown over the forest for 100 hours. And what typically would happen was that there'd be a PhD student whose job would be to sit there and have 10 cups of coffee and try and say and count animals. Before even tagging.
Just count what's
by
there.
eye. So it was by eye. And then it was and people were trying to develop their own machine learning models, which is all well and good, but we've developed something which we call conservation AI. So Paul and Carl's is there, the sort of where they've taken really the cutting edge machine learning in computer vision, and so anyone can upload their data, and you say, right, here's my data, you put it in the pipeline, and it'll say, right, there's this animal here at this location, and the idea is that it speeds up going from taking data to doing actionable things like, right, we need to put a fence here, or this is where the poachers are getting in. That kind of thing. The ecologists need to know that as soon as possible to deal with the problem.
Yeah.
And so we're basically fast-tracked that.
Fast-track the manual looking through.
Exactly. And so now, I mean, the system, we've got camera traps in different projects, and we can... there've been some project we're working on where they're interested in poachers, and so for example in pangolins in Uganda. So pangolins are these, I don't know if you've seen them, there's these, have a look on the web for what pangolins are. They're kind of like pangolin, yeah.
Oh yeah, I only know about pangolins because
I'm gonna have a look.
Have you seen the South Park special about COVID?
No.
Have you seen it? No, well, apparently COVID started because Randy in South Park had sex with a pangolin. Like, that's the only reason I know what a pangolin is.
One of those.
They're pretty odd looking things, but they're
kind of like
really
armadillos.
They're kind of like armadillos, but yeah, they're super exciting, and they get poached.
What did they get poached for? This is very off piece, but
it's very off piece. They get taken to basically China, where they're, I think,
food market or medicine market.
Yeah, and there's a huge price for these things, I think. I'm not sure. So but yes, we basically have the system that a human appears in the camera footage where there shouldn't be, and it's immediately inferenced. It's a text message or an email sent within 2 seconds.
Like real time tracking.
In real time, 2 seconds from detection to the ranger, who can then make an intervention if that human's not supposed to.
So this is not from drones then? This is from
that's camera trap. So we're
camera trap.
So the algorithms don't care. I mean, it doesn't matter where the data come from.
Yeah.
It's agnostic. So it works with camera trap data. It can work with audio data if you train the model correctly. But it's training the model for the environment and the species.
What I really like most about this is the fact that it's actually a deployed piece of
it's out
development.
There. Yeah, we're working with Chester Zoo, working with Knowsley Safari.
Because it's great because a lot of machine learning stuff tends to stay in especially in healthcare, it tends to stay in the realm of, well, we've done a thing, we published it, this could work, but it's
the transition, exactly. It's the transition out there, and I think that's what Paul and Carl have been so successful in. It's this end-to-end application of
real-time application where you can see what we're doing.
And it's operating in the field in tens of countries and all different continents, and so I think that's I really hope that it's going to have a sort of long-term impact in these general areas.
So is there a website that people can go to?
Yeah, Conservation AI.
ConservationAI.com.
I think if you just Google Conservation AI.
We'll put a link to it in the description. So if you have any footage, upload it. Help the guys out. Help yourself.
Absolutely.
We'll see what happens.
Did you guys? I was sorry. This is might be even more off topic. I was at. You mentioned Chester Zoo. I was at Chester Zoo, and in the elephant bit, there was this like PhD student who had used cameras on the elephant compound. Is that you guys?
I have no idea.
No, sorry.
There's
loads.
There's lots of different researchers doing that. So I don't want to say yes and it's not.
No.
we do lots of things, and there's lots of different projects and PhD student.
Is there loads of? I was just thinking about the applications of like sort of astroecology, if you like. Then outside of, I suppose, animals, you could use it for like, I don't know, track a natural disaster like a wildfire or.
We do fires.
You do fires. You do
thermals. So we were in. So it turns out that
and basically with a signature.
Yeah. Well, so we work with people all around the world so fires are a major problem for deforestation. Also for peat fires in particular are a major source of carbon being released to the atmosphere. Peat is an amazing sink of carbon, and so Indonesia, for example, there are some years where the peat fires release more carbon than the whole of the world transport together. Just one peat fire, then everything, planes, cars, the whole lot, the peat fire outdoes it.
Just because it's such a good
carbon store. And the problem is that it burns underground. So it's not like these flaming forest fires, because peat, as you know, sort of is in the ground. So you see all the smoke, but where the hell's the actual fire? And it takes something like 100 litres of water to put out 1 square metre of peat fire.
Shit.
So and then it's in the middle of nowhere, and you're far from a river, so if you're going to, you better point your hose in the right direction, so to speak, right? So we've worked with people in different places to use thermal drones to pinpoint exactly where the hot, and it can see through smoke because it's the thermal. It sees through the smoke. Boom, pinpoint it, put out the fire, and so it's another kind of application.
And catch them, I suppose.
You got to catch them early, because by the time they get big, you forget it. I mean, if you think 100 litres of water for 1 square metre.
For a square metre?
1 metre squared,
100 litres for a square metre?
Yeah, it's ridiculous. Yeah, once it's properly burning.
It doesn't even make any sense if you look at it. 100 litres of water for this metre.
Is insane. But it's because the peat can be several metres thick and it's all burning. So you imagine you're just trying to put out your backyard. You know, if you have your bonfire that's coming up soon, right? Bonfire. Right? Imagine how much water it takes to put that out when it's absolutely raging, and then you've got.
But that's several metres on the ground.
That's several metres, and it's also.
Is there any applications then, Stephen, where you're looking to use astroecology? Where you're thinking that could be definitely useful? We just haven't got the tools or the protocols in place to make moves in that field.
I mean, I think it's such a general. The thing that we're developing is such a general problem. It's like finding and identifying things, right? And you can think, you sit down, you have a beer, you come up with 5 ideas, and we'd love to explore all of them, but we're just. It's just time and
time, money, and manpower, basically.
Absolutely. You've hit it, So,
that's brilliant. So I suppose then, what's coming up next? What's in the future for yourself, the astroecology, astrophysics? What sort of things have you got coming up on the horizon?
Okay, so I guess take them one at a time. So on the astrophysics side of things, I mentioned before about the technology being a big driver. So. The big telescope was just the launch as the James Webb Space Telescope. So I've been lucky enough to be awarded time on that.
Oh wow!
So I'm excited to be using that data, and we're frantically trying to work on it and publish it. So I'm excited about, because that telescope's just phenomenal. It's really phenomenal.
So how does getting time on that work?
Yeah, so it's the way it works, and this is pretty general to all telescopes, is that a telescope will put out a call for proposals. So the James Webb will say, right, on October, there's one coming up. So on October 26th is cycle 3 call for proposals. Anyone in the world can apply.
Oh, wow.
Okay? And then, so groups of scientists get together, and so I'll work with my colleagues and I'll say, hey, I've got this idea. I want to look at this object for this long at this wavelength, and this is my science question. So we get together and we write that. But of course, there's like everyone's doing this.
Yeah.
And then so there is all those proposals get submitted and get sent to the time allocation committee. So these are astronomers from all around the world that read the proposals and basically rank them on the top. So say there's 1,000 proposals, and there might be only 10 to 50 that actually get time, and then they're ranked, and then those ones get time, and those people eventually get the data. That's kind of how it works in general. So I was lucky enough to be one of the first people to get data on that.
How much time have you been awarded?
About 30 hours.
30 hours.
So yeah, it's cool.
That's
It's
cool.
really cool, and the data is
So-
mind-bogglingly good.
So what? You don't have to share it if you want to keep it a secret. But what is the general thing you're going to?
I'm very happy to share it. So we're trying to find forming stars and planets in the center of the galaxy. So we found a cloud that we think is. Remember, I was saying that the gas is collapsing. We found a cloud that's collapsing, and we've been given time to look, and so James Webb can peer inside it. So it's just like the thermal infrared. Like we're seeing a peat fire, it can see through the smoke.
Yeah.
Well, James Webb can see through the smoke
Cloud,
in space,
basically,
through the cloud, and we can see the forming stars and planets. So that's what the James Webb.
So you can
data-
actually see them
can
forming.
actually
in the...
see them. Yeah. So that's
so
yeah,
cool.
it's amazing.
That's
it's really
sick.
cool. And of course, and because it's the center of a galaxy, we think the conditions were like when we were forming. So we're going to learn something about hopefully how we formed.
Then use the conjecture and apply it to our
Exactly.
whole process.
Exactly.
Because of the nature of the universe, you'll be looking back in time. won't
Yes. Yeah. So it's 8.5. It's 8.5 kiloparsecs. So it's like we're looking 20,000 years or something.
you?
like that.
That's when it starts confusing
Yeah.
you.
So
And it's
good,
like,
isn't it?
It is.
we found this, but this didn't happen yesterday. This happened ages ago. It's
It is
just like,
mind-boggling. Yeah.
what? Okay, that's cool. So astroecology then, what's...
Yep, astroecology. So we are trying to have a way that we can scale up what we're doing. So that's the next thing that we really need to do is that there are lots of potential projects. So I think the core of what we're doing is there. We've shown it worked. And we really want to try and maximize that for the benefit of these different projects or organizations. And so that this is what we want to do, is really to find a way that we can make that freely available to...
You need a satellite, man.
Well, maybe satellite, yeah.
So is that more on the software front or like a hardware front, like have a cluster of servers potentially people run
That is
on?
a banging
or...
question. That is, so it's a combination of both.
Right,
Is that
okay.
it's the infrastructure to be able to quickly process. So say there's an immediate need, someone comes to us and say, look, we need mountain lions. We need somewhere
Quickly,
to
you
we need
can get
quick.
to
There's
that
this
job.
need. We need to be able to tag that to get the sort of end-to-end solution in place quickly, and that. So there's that. And training these takes a lot of GPUs.
Yeah, I can imagine.
So yeah,
It's
you
all
need-
images, isn't it?
Yeah.
Absolutely
Yeah.
everything, yeah.
So that's the kind of next step. So is to kind of try and maximize the potential of what we've developed to try and help best.
So interesting, because again, it's a slightly different question on what you've already answered. Again, it's that whole element of trying to get. No, so interesting. I love it.
Well, should we do the famous...
Yeah.
Oh,
So,
no.
so before we finish up,
Oh no, I failed on the falafel. How am I gonna
Nah, the falafel
the
was
falafels are
good, man.
great. But
Falafel
so
was
before we
good.
finish up, we ask 2 final questions.
Yeah.
So the penultimate question
Yeah.
is Sam's famous question.
Oh shit, thought you were going to do the one.
No.
Yeah, no, here's my question, Stephen. I feel like I know what Stephen's going to say, but
Same.
it's like a question that his whole field asks
Oh, okay.
every
Yeah.
day. No, so you're on your deathbed, Stephen.
Yeah. Am I? Oh.
Sorry,
I've
mate.
just put you on it.
Okay. Good.
You were nice and healthy before you came in.
You're on your deathbed, you've just been found out, unfortunately, tomorrow isn't going to come for you.
Yeah.
What is the one thing you want to know that you currently do not know that will make that goodbye, that good night a little bit more, okay, I'm happy I know that?
is there intelligent life in the universe?
Yeah.
I didn't even need to think about it.
That was one that was written from this minute we started.
Yeah, that wasn't written for an astrophysicist. It was written for everyone else.
Yeah. So the final question is what we like to end on. So what we've done, will be going out soon, is we've compiled a little playlist.
Cool.
So when we have guests on, what we like to do is we like to ask them what is their favourite song of all time.
Or the song they're listening to at the moment.
Totally unfair. It depends what mood I'm in.
So there's kind of a
okay,
little
no, I've got like
right.
So I'm gonna go happy. You know, like I'm so happy.
Pharrell Williams.
Nice. I love it.
That's out of Despicable Me, isn't it?
Because so as on Fridays, like after I've got 2 kids and after school, so they've got their playlist, and that's like number 1 on their playlist. So because Friday afternoon, I played football, I might have had a beer. I get home and we put on the and that's so it's, exactly exactly. I mean we do a bit of shoddy dancing in the kitchen.
But that's the best thing about music, isn't it? It's the memories it brings with you as well.
Yeah.
Right, we'll add that to the place. That's another belt. It's another belt. I don't think we had one bad one. Our mate, he's a City fan.
Oh, well,
and he had what is it? Blue Moon.
Blue Moon.
He got us Blue Moon, and we were like, I can't believe it.
Yeah. Shocking.
So thank you very much for coming on. It's been such a wonderful conversation.
Thank you,
so
Stephen.
interesting.
Really
thank you for your time.
Thanks for inviting me.
Thank you everyone for watching and listening. If you did like it, leave us a like button. If you didn't like it, well, we don't like you, but thanks for watching anyway. Do you know what I mean? They give us a view anyway. Comment if there's anything you want to know. Make sure you click the links in the descriptions to go to Conservation AI. Check them out. They're doing great work. And yeah, we'll make sure to see you in the next one.
That's it. Peace out, people.
See you later.
Cool. See you in a bit.